Cyclones are powerful storms born over warm ocean waters near the equator. These warm waters act like a giant fuel tank for cyclones. Ocean temperatures need to be at least 80 degrees Fahrenheit or 27 degrees Celsius for a cyclone to form. This warm water evaporates into the air much like steam rising from a boiling pot. This warm, moist air is the first ingredient in our recipe for a cyclone. Imagine a large pot of water on a stove. As the water heats up, it turns into steam and rises. This is similar to what happens in tropical regions. The sun's heat warms the ocean surface. As the water warms, it evaporates and rises into the atmosphere. This rising air is full of moisture and heat, creating an environment ripe for cyclone development. Without this warm ocean water, cyclones wouldn't have the energy to form. The warmer the water, the more potential a cyclone has to grow stronger. As warm, moist air rises, it leaves behind an area of low pressure near the ocean surface. Air moves from high to low pressure, trying to balance things out. More air rushes in to fill the void left by the rising air. This creates a powerful feedback loop. Low pressure areas are crucial for cyclone formation. As the air rushes into the low-pressure area, it doesn't just flow straight in. Instead, it gets deflected by the Earth's rotation. This deflection is called the Coriolis effect. In the northern hemisphere, the Coriolis effect causes the air to curve to the right. In the southern hemisphere, it curves to the left. Imagine you're trying to roll a ball straight across a spinning merry-go-round. Instead of going straight, the ball would curve as it travels. That's because the merry-go-round is rotating underneath it. The same principle applies to the Coriolis effect. The Earth's rotation causes the air to curve as it moves, giving cyclones their spin. This spinning motion is a key characteristic of cyclones. Without the Coriolis effect, the air would simply flow into the low-pressure area, and the storm wouldn't develop its signature rotation. As the warm, moist air continues to rise and the Coriolis effect sets the system spinning, the storm starts to organize and strengthen. Meteorologists use a specific classification system to describe the development of a cyclone. It starts as a tropical disturbance, a disorganized area of thunderstorms. As the disturbance gains strength and its wind speeds increase, it graduates to a tropical depression. At this stage, the storm has a defined center of circulation and wind speeds between 23 and 38 miles per hour, or 37 to 62 kilometers per hour. With further intensification and wind speeds reaching 39 to 73 miles per hour, or 63 to 118 kilometers per hour, the system becomes a tropical storm and receives a name. Finally, when wind speeds exceed 74 miles per hour, or 119 kilometers per hour, the storm is officially classified as a cyclone, also known as a hurricane or typhoon depending on the region.